Hey guys, Jared here, and today I'm going to show you how I upgraded the CPU in my desktop to 6 cores for just $26. For almost 7 years now, I've been running a first generation Intel i7 950 quad-core CPU at 3 GHz. And for the most part, it's been fine for me. I've only started to notice issues over the last year or two while I've been creating these videos, as rendering can take quite a long time. While I'm very keen to upgrade to a more up-to-date computer, I'm still playing the waiting game, as Intel recently launched Skylake X, which seems a little disappointing. But more interestingly, AMD is about to launch Threadripper. So until all the new CPUs are available and I can decide what to get, I wanted to see if I could upgrade what I have on the cheap. My current 45nm CPU uses socket 1366, and after some investigation I found that the socket also supported slightly newer 32nm Xeon CPUs with up to 6 cores. So I hit up eBay to see what other CPUs that use socket 1366 were available. In the end I settled on the Intel Xeon X5650, which is a 6-core CPU at 2.66 GHz that can turbo up to 3.06 GHz. So it's clocked a little slower than my i7, but it does have 50% more cores. At just $26 delivered from China, I just had to know how it performed. A couple of weeks later, my cheap Xeon arrived, and I started running a ton of benchmarks. Let's take a look at the results and find out how the $26 hex-core CPU goes against my quad-core i7. In Cinebench, the i7 got a score of 487, while the Xeon got a slightly higher result of 646, which was expected as this test really favors more cores. I then used Adobe Premiere to render my recent 970M vs 1050 Ti video at 1080p, which is just under 5 minutes long. The i7 CPU completed the task in 13 minutes and 33 seconds, while the Xeon chip completed the same task a little quicker at 12 minutes and 12 seconds. So not much of an increase, but still nice to have. I've used Handbrake to encode a 500MB MP4 video file that I recorded from 1080p to 720p. The i7 completed the task at a rate of 22 frames per second, while the Xeon was ahead at 29 frames per second. But again, this test favors multiple cores. Next I ran the 7-zip benchmark with a 16MB dictionary. The i7 received a score of 17,006, while the Xeon performed a little better with a score of 22,372. So we can see the extra cores are improving overall compression and decompression speeds. Geekbench 4 performs both single-threaded and multi-core tests. We can see here that the i7 CPU performed slightly better in the single-core test, which is to be expected as it's running at a higher clock speed than the Xeon. In the multi-core test, however, the Xeon pushes out in front as expected owing to those extra cores. In the Passmark CPU benchmark, the Xeon CPU came out ahead again in all tests, except of course the single-threaded test as expected just like before. In the Corona benchmark, the full image was rendered in just under 7 minutes with the i7, while the Xeon completed the same task in just over 5 minutes, so almost a 2-minute difference there. Next we're going to look at some more graphically focused benchmarks, as well as some games. For reference, I'm using an AMD 6990 graphics card in the PC, so let's see how much difference the slower clocked Xeon makes in games. In Heaven benchmark with the quality set to medium, tessellation on moderate, and anti-aliasing set to 2, the Xeon CPU performed almost 1 frame per second better. In the Valley benchmark with the quality set to medium and anti-aliasing on 2, the Xeon CPU actually performed 5 frames per second worse compared to the i7. In the 3D Mark Skydiver benchmark, the Xeon CPU came out just slightly ahead with over 17,000 points, while the i7 was around the 15,500 mark. In Ashes of the Singularity, the i7 CPU scored 16 frames per second with the built-in benchmark, while the Xeon was only slightly behind at 15.6 frames per second, so hardly much difference. Both aren't really playable in any case. In The Witcher 3 with medium settings, both CPUs performed at 45 frames per second, so basically the same, which was pretty interesting. Based on all of these benchmarks, on average the 6-core X5650 Xeon CPU performed 13% better than the i7 950 quad-core CPU. I expected the better single-core performance of the i7 to give better gaming results. However, it seems that the slightly slower Xeon CPU is still a match for it. All of my benchmarks were done with stock speeds, no overclocking has been done at this stage. However, I'm interested in testing this in the future, as from what I've read it should be possible to overclock the Xeon chip above 4 GHz, so that could change things quite a bit. There are slightly faster clocked versions of this CPU available, like the X5670 and X5690 for instance. However, they cost quite a lot more, up to double and triple in some cases. So I figured it'd be better priced performance to get this 2.6 GHz one and overclock it later instead. In terms of temperatures, the Xeon chip actually ran cooler, both at idle and under full load. Both CPUs were cooled by my Cooler Master V10 cooler, which did a pretty good job, so I think we've definitely got enough cooling capacity to try to overclock and get even more value in the future. In general, the Xeon CPU does a pretty good job at keeping up with the i7. The Xeon obviously dominates in multi-core workloads, as it has 50% more CPU cores. However, even though it's clocked slightly slower than the i7, it still does quite well in single-threaded tests. The small handful of games and graphical benchmarks even show that it doesn't make that much practical difference. So I'm going to stick with the 6-core Xeon as it gives me a small boost in various productivity use cases, such as video rendering with Adobe Premiere. So what do you guys think about my cheap upgrade to 6 CPU cores? I think that low-priced Xeon CPUs offer a cheap upgrade path, potentially allowing you to get more life from an otherwise outdated computer. Let me know if you've picked up any cheap Xeon CPUs for your PC and how they perform down in the comments. And leave a like on the video if you found the information useful. Thanks for watching, and don't forget to subscribe for future tech videos like this one.